Hey, hello, y'all, welcome back, and welcome to my channel again. I think I'm going to post this video in the new year, so Happy New Year to all of you, and I hope you all survive 2020 and no ill effects from that, because we all know that wasn't the greatest year, and let's hope 2021 is a lot better. So glad to see you guys back. Okay, I'm going to start off the year with a Sony, old vintage Sony receiver. These are kind of cool to me. I've never really had any experience with vintage Sony stuff. You know, back in the 80s and stuff, we didn't really listen to Sonys or have them around us. This one's just a plain Jane AM/FM receiver. It's an STR-230, or sorry, STR-230, not 2030. Pretty basic. It's got switching between two sets of speakers, remote or main, but you don't get to choose both, and you don't get to shut them off. Power switch, volume, balance, bass, treble, loudness button, pretty vanilla controls here. High filter, mono stereo button, and then your AM, FM, phono, tape. So I don't know if there's anything wrong with this thing. I happen to think it might be actually working. Yeah, oh yeah, look at this power cord. It's like 10 feet long. It's ridiculous. But let's plug it in and power it up, just to see what's going on inside the thing. Oh, it's already turned on. And we are on AM. So we'll just scan the band here. And the tuning meters weren't working. Lights are working, and lights are on, somebody's home. FM, I'm still getting a little bit of reception even though there's no antennas hooked up. So let's get speakers on this thing and see what it does or doesn't do. Just a quick look at the back. It's got one courtesy outlet. It's got goofy RCA jacks for the speakers, the remote and main. And then it's got 3 inputs, phono, tape, and it's got 2 inputs, phono and tape, and then it's got a record out. So magnetic ceramic switch for your phono, and then your AM antenna connections. So let's get this hooked up. Let's go for the main and see if we can get this thing to squeak some noise to us. Alright. A little thump in the speaker.
See you tonight.
Holiday choice was your parents or the in-laws?
He fills up his tank at mobile stations, conveniently located in the parking lot of his favorite grocery stores, where he earns PC Optimum points. Brian's intelligent design gives him the foresight to fill up when he's already there shopping, rather than on a separate trip later. Fuel efficiently, like Brian. Get your gas at a mobile station. Is not an option. This is the Roy Green Show.
My balance pot's messed up badly. It's not even working on one side. Volume pot's pretty scratchy. AM's working great. FM's working okay. I think if I put an antenna on it, it'll wake it right up. Full blast. Seems to have some, let's try AM again. Seems like the AM's got some volume, but the FM doesn't.
Vous devez heureux et pour éviter les infections, il faut le garder propre. Oui, ça veut dire changer sa couche. Ça veut aussi dire de bien nettoyer tout ce qui doit
can see the lights flashing with the audio. So maybe the power supply is weak. Phono. Got some hum. Got some hum on tape too. Okay, so far it's just working, but it's just got dirty pots. I don't know if there's anything really to do to this other than clean pots. It doesn't make for a very good video. Let me see, let's take the lid off, have a look inside. So there's like 7 screws in the bottom, you have to remove them, and then the whole chassis slides out. Have the, oh wow, look at the dust bunnies in this thing. Let's have a look at this. Okay, so here we are. Look at the insides. We got our tuning capacitor is just full of dust. I'm surprised it was working. And our tuner is just coated with the stuff. And there's in the power amplifier right here. We've got dust everywhere, everywhere. Check out this little tiny filter cap for the power amplifier. It's like 1,000 microfarad. That's kind of a sad display there, but let's get this thing outside and cleaned up, because looks like we might be doing some work on this. I don't know. It's working now, but we're going to check some caps. We're going to see if we got bad caps in this thing. If we do, we're going to be changing some. So just stand by. Let me clean this up. Okay, now that I got it cleaned up, we can have a good look at it. It looks like it's really good shape, and it looks like it's never been touched or serviced before. The capacitor cleaned up really nice, which is good. I was worried about that, but that dust, it just seemed like a lot of lint. It didn't seem like dirt or anything corrosive, so it was just lint. Looked like maybe from clothes or something. But I was looking through the tuner here. I don't see anything going on. Everything looks good, except we don't know the condition of the electrolytics. There's a little bit of circuit glue around this inductor here in this cap. It's pretty much the only place I see it. If you look in the power amplifier, there's these 2 big caps on the output to the speakers. They have circuit glue around them as well, and I'll probably address these caps. They'll probably be they're 35 volt, 470 microfarad, and I usually like to increase these in capacitance, and gives the amplifier a little better bottom end response. It's got this tiny little 1,000 microfarad cap. I think we're going to deal with this. We'll probably replace this with a 4700 and see what improvements we can make to this amplifier. Look at this. It's got these thermocouples, or not thermocouples, but thermal resistors, and they're bonded to the emitter resistors. I've never seen that before. Usually if they want to do any biasing or temperature sensing, they go to the heatsink, but here they're going right to the emitter resistors. I don't know what the thinking is behind that, but we'll probably end up leaving that alone. Not much else to say here. Bulbs we can do. The bulbs seem to be all working, including the one for the meters, or meter. The soldering all looks intact and original. I don't see any obvious cracks in the solder joints yet. The dowel cord is nice and clean. It's white. It's unusual to see it clean like that. Let's have a look on the underside. So we got the underside, the tone control board, that preamp. Got a little bit of power supply going on here with a fuse and a couple of rectifiers. And the bottoms of the tuner. Like I said, I'm not seeing any cracked solder joints just off the top of the head here, but I'll give it a good look. Look at this on the power amplifier. They got these rings around each transistor leads. I don't know why they do that. Why would they do that? There's a potential for short circuit there. Look at that's only a millimeter away from the collector. I don't know why they do that. Bend that away. I guess they do that to make the connection to the board, but they couldn't have just put a nut on there. I don't know what the reasoning is behind that. Seems like they're using this as an electrical connection here, because this comes through from here and then it continues to here. So I don't. That's pretty poor design, because that, you know, if that screw goes loose, you lost that connection, and then your amp usually grenades. Oh, see, and here's the same thing on this one. It looks like it's fed through this ring and then back out again. So maybe we can address that. I'll have a good look at it. I don't have a schematic for this, or a service manual. I do have one for another model that's similar. It's I don't even know the number anymore. It's off the top of my head, but I'm gonna have to see if they're similar in design and if the schematics match. If they are, great. If they don't, well, we're working blind here. So I think the main culprit on this is going to be caps. We haven't tested any yet, but we're going to see how bad they are, and depending on that, we'll determine if it gets a full recap or if it's just going to get spot replaced. So I think what we need to do now is hook this up to a scope and a dummy load and get a baseline performance reading on how it's going to work before we do any work or modifications. Alright, so we're all wired in for a power test. Both sides into an 8 ohm load, 1000 hertz tone. Got my voltmeter hooked up. Let's turn up the volume. And the left side, which is the top, is quite a bit less than the right, which is on the bottom, which is already into clipping. And you can see that effect of that weak power supply capacitor on the bottom trace. It's already into clipping, and you can see that flutter. Let's turn it down a bit until the clipping stops, right about there, and we are getting 7.9 volts RMS output. A little concerned why one channel's louder than the other. Let's try the balance control. It doesn't completely cut it off. Oh, there it is. It's pretty dirty. Balance control is pretty dirty. Even the volume control is scratchy. Treble, scratchy. Bass is scratchy as well. And dirty switches as well. Okay. Good. Let's try a little higher frequency. This thing's on full power right now. It's barely getting warm. And this is all cold too. Not much heat here. Let's, I want to measure the output on the other channel. So let's switch my voltmeter around. And on the low channel, the left, I am getting 6.36 volts, considerably less. Let's increase this. Turn this up to 1.5 volts. And we'll try this one more time. Okay, we got clipping on both now. Now on the left channel we got clipping on the top, no clipping on the bottom. The right channel we got more clipping on top than bottom. If I back it off a bit, you can see that the clipping on both the tops. That tells me we've got some imbalance in the power amplifier. We need to address that as well. I don't see any adjustments here for bias, so we might have to go in and fool around with some resistor values. We don't know yet. We're trying to get that balance back out again, but that's not acceptable. Top amplifier is at 7.9 volts RMS. That's max. I guess that's the same as the right channel. So it's a good start. I think let's try some higher frequencies. Okay, let's start this off here. Keep it out of clipping. Let's turn this up. Seven kilohertz, 10, 15. And you can see the difference between the two channels. Yep. 16, 20. I'm getting any distortion? A little bit. Okay. I think the first thing we need to do is address that filter cap. Pretty convinced it's bad already, or it's inadequate. Let's measure this filter cap and see how it's doing, and then I'll replace it with 4700, and then we'll see if we get a better performance out of this. Alright, so I disconnected the power lead from the positive end of the cap. It's unplugged, of course. Yes, it's unplugged. And let's connect up our meter and see what we get. So we're down to 822 microfarads on a 1000 mic cap, and we're 67 milliohms, which is a little high, I would think. Let's see here, frequency. Turn it to 120 hertz. Yeah, 850 microfarads. That cap is weak and done. Let's tack in a 4700, just temporary, just to see how it performs. Okay, I tacked in a 50 volt 4700 microfarad in place of the 1000. The scope's hooked up. Let's try this out. And we'll see. Why do we have nothing? Oh, it's because it's not plugged in. Alright. Okay, we can take it up to clipping, and we no longer have that flutter on the top. We still have clipping on the top before the bottom, which is a problem. So let's back this off a little bit. Where are we? We're scoping channel. The left channel. Okay, so let's take the left channel to clipping. I think that's right there. We got 8.68 volts on the left channel. Let's check the other one again. Let's check the right channel. Take this up to clipping. Right there, I'd say 8.3 volts RMS. I'm still at 20 kilohertz here. Hang on. Let's change this. There we go. Let's see it a little better. .9 volts on the right channel. So I think that little improvement there with this cap, I'm going to leave that in place. I'll properly mount it, and we'll, I don't know if I can mount it here or not, but we'll go with this upgrade, and then we'll have to check all these other caps. These two caps here, I suspect, are probably old and weak too. These are the output capacitors for the speakers, and they're probably a limiting factor on this amplifier's performance as well. So we're going to go and have a good look at these. We'll probably upgrade these as well, along with all the other ones. This thing's barely getting warm, running full power. I don't know what it's rated at. It seems to be built up to a spec though. It's not going to blow up anytime soon. Alright, so I'll get my cap meter out and I'll start checking everything we can get a hold of. Okay, I'm working my way through the power amplifier. I've done a number of modifications, well not really modifications, maybe upgrades. On the output, speaker output capacitor, I upgraded it from a 470 microfarad to 1000, and I'm gone through and I replaced all of the caps, electrolytic caps in this circuit. And even though they pulled out and I tested them, they are good. I'm putting audio grade caps in, and I'm putting brand new caps in just as a base for what we're trying to do here. I guess what my goal is, I was trying to improve the performance of this power amplifier. When I first hooked it up and we did the power measurements, that was our baseline, and I noticed there was a couple of problems. One was the biggest and most obvious problem was the power supply capacitor was weak, and it was creating a lot of ripple, and we got that fixed. Now I'm going to move on to the power amplifier because I noticed when we were doing the tests there was some distortion on the screen, the oscilloscope screen, some crossover distortion, and I have the feeling this amplifier has a biasing problem. And also, when we were doing our tests, the clipping was not uniform either. Like it would clip on the top swing of the voltage before it would clip on the bottom, and that's all a function of biasing. So I'm looking at this amplifier and going, what's wrong with the biasing on this? There's no adjustments, but it's stuffed with all these old resistors. And I just want to give you an example of two resistors that I found so far. I just started, okay? And here's this one here is a 470 ohm resistor, 10%. Let's measure this one. And we can see this one's up at 525 ohms from 470. So that's out of tolerance. That's out of the 10% tolerance range. Here's another one that is 100K, and this is also a 10%. And this one rings in at 116K. So I obviously have a problem with resistors here. Let's try another one. Here's a 470. See, that one's out of tolerance too. Another 470. That one's barely within tolerance at 10%. Let's try another 100K here, if I can find one. Here's 100K. No, this one's not. No, that one's not going to reveal itself. So, oh here, try this one. No, same thing. So my plan is to go through and test all these resistors and replace the ones out of tolerance. Look, there's another 100K resistor. It comes in at 120, 127. So I think that's our biggest problem here with this amplifier for biasing, is the resistors have all gone to crap. And what we're going to do, I did find the schematic for this. I have a schematic now. This is the amplifier section, and this is the tuner section. I'm going to go through and make sure all of these resistors are 100% before we continue. And then I'm going to start thinking about replacing the complementary pairs for the drivers, just to see if that makes any improvements, because when this amplifier was built, they didn't have a lot of selection on quality transistors. They had, it was pretty much, how do you put it? They were limited in what they had there to work with. So now that we have more modern transistors that are better behaving and better, you know, performing, we're gonna maybe try swapping out the drivers, and maybe even I'll swap out some outputs too to see if that makes any improvement, or if that's just a waste of time. So bear with me here. Alright, so I finished a lot of work on the power amplifier. What I've done is I replaced all the caps, and from here it looks like I replaced about 20 resistors that were out of tolerance. So this receiver has a bad case of resistoritis, and it's not just the power amplifier. I'm looking at the tuner, and I'm doing some spot checks with an ohm meter, and resistors are out to lunch. So I might have to go through and redo this board as well with resistors, because from what I saw in the power amplifier, it was pretty bad. You know, you get a 10% tolerance resistor and it was out by 20%. So what I did is I replaced them, all of the ones that were out of tolerance, replaced them all with hand-selected components that were pretty much bang on. So they're all within 1% now. So now let's hook it up and do another amplifier test to see what kind of improvement we made, if any. So let's switch this on. I'm going to feed it a 1000 hertz signal. And no smoke, that's good. So let's turn up the volume here. Turn on the generator and turn up the volume. Now it's full volume and I'm not clipping. Let me give it some more. Let's feed it with 2 volts. That way we know it's going to go into clipping. Okay. So the right channel is again seems to have more gain, but look at it, this time it's balanced. The clipping is happening equally on both bottom and top, and they both start about the same time. So let's see if we can get the other channel clipping as well. Yeah, there it goes. So they're symmetrical now. They're not out of balance like they were before. The right channel's a little bit higher gain. And what channel am I scoping here? I'm scoping the blue. Okay, let's get the blue to clipping. Right about there. And I am generating 9. What's going on here? It's fluctuating a bit. Right there is clipping. And I'm getting 9.97 volts RMS. So I think we've come up considerably from before. We still need to address the imbalance between the 2 channels. Balance control is working, but I don't think that's the culprit. Right there is the center, and still we are Okay, now what I want to do is I want to take it up to 20 kilohertz, and I want to observe the distortion that I saw last time around and see if it's still there. So let's take this up now. Frequency. $20 kilohertz. Doesn't seem as bad as it was before. So I'm looking at this and it looks relatively distortion free, even though I'm running it to clipping. Back it off a bit. Looks fairly clean. This is 1 kilohertz. I think this amplifier has seen a lot of improvement. Alright, a couple things. One is I need to change the dial cord on this because I screwed up and I cut it. I don't know if you can see this here on the camera. If I zoom in maybe. You can see where it's been chewed up. What happened was I had the reflector for the lamps out, and then when I put the reflector back in, it actually, I didn't see it, but it was actually, this wire was underneath the sheet metal, and then when I started fiddling with the knob, it got pulled both back and forth and it got cut. So I'm gonna, it's not cut right through, but the woven cover of it is cut through, so I'm going to change it. I'm going to see if I have any cord around, but we'll deal with that in a bit here. For right now, the knobs, these are the knobs for the receiver. They're plastic knobs and they have a aluminum inset that's polished, or not polished but brushed in that manner. And the tuning knob was missing the aluminum insert. So what I did is I took a sheet of aluminum and with a pair of tin snips I cut a disc out of this aluminum. I measured it and made it so it fits. So what I'm going to do is I'm going to hot glue this in place, and then I'm going to mount the entire knob assembly in a drill, and I'm going to spin it, and I'm going to put it that same brushed effect on the knob that the other ones have, so that it matches. So we'll see how that turns out. Okay, so here it is glued on with hot glue, and it's not perfect, but it's definitely better than what it was before. It's not perfectly round either, but I did try to get it close. When I cut it out, it wasn't round at all, so I had to file some of these edges off. So let's put this in a drill. If I can get the drill to grip it. Just like that. I need some room to work here. Hang on. Okay. And I got some emery cloth. I'm just going to go easy at first. That's the problem with getting it centered. So I did some more sanding and I got it down to the point where that flaw is gone. You got to be careful because if you do too high of speed or for too long, it heats up the aluminum disc and then the hot glue lets go and then your disc goes off. So you have to be aware of that. But I just want to get this finished. It looks like it's pretty much done. Except it wants to come loose. Somehow I got this thing off center. If it's off center, you can always readjust it. Okay, I'll try that. It's not too bad. Okay, when you're done and you think you got it finished to the point where you like it, get some of this and polish it. Now, how does this look? This one definitely has a higher polish. This is a sanding finish. But I think it will be okay. So here's what it looks like when it's finished. Here's a couple of the original knobs. And it's not too bad. I think if you wanted to take it further, you could polish it. See, it's got no coating on it whatsoever right now, and it's susceptible to scratches. But I think if you wanted to coat it with a clear coat, that would make it look like this. Or you could get a metal polish, and you could really make this shine. Probably more than these do if you were aggressive on the polish. But if you went easy on it, and the beauty of this is if you don't like the finish, you take your sandpaper and remove it, erase it, and start over. Yeah, I think it's going to be okay. I'll leave it like that. I might coat these. I think I might coat this. I'll tape off the outside and I'll spray it with a clear. I'll clean it well, spray it with a clear, and then I'll call it done. Make sure there's no scratches that I'm encasing. But I think it turned out all right. All right, one of the improvements I made to this Sony receiver is when I replaced the filter capacitor, I yanked out these wires. Now have a good look at these. These were in the power circuit, and these are 25 gauge wires. I don't even know if you can read it. It's so small. I measured it 24 AWG, but I measured it and it's 0.45 millimeters, which equates to a 25 gauge. So you got to appreciate these little tiny wires in the power circuit between the power supply and the power amplifier, and they add a considerable resistance. How much? Well, let's figure it out. Here, I'll measure these wires. So what I did is I just soldered the wires together to make one longer wire, and it's probably 22 inches long. And I'm just going to hook it up to my bridge here and see what it measures in resistance. And it comes out at 50 milliohms. $51 milliohms. Okay. So I eliminated a 51 milliohm resistor and I replaced it with 16 gauge, and this will handle the current. This is only rated for half an amp. But 16 gauge is rated for much more, so it'll improve the amplifier because it's getting a better regulated supply of voltage, it's getting a higher current, and you know, it has I eliminated a 51 milliohm resistor in the circuit. So before you start restringing a dial cord, if it's intact like this one, is you want to take a photograph of how its path and how it's wrapped. You know, you pay attention to how many wraps on this shaft. There's 3 here, and which direction it goes, and which pulleys it sits on. Just take photos or draw a picture or whatever diagram for yourself. Another thing you should do is hit the pointer all to one end and then just put a mark so that we can realign our pointer after, so that I have some place to go with realigning, because this is just glued on and I'm going to remove that. I can remove it right now. Glue it in with some there we go. Okay, so that's loose. And then we just take it off from the pulleys. And take it all off. What I'm going to use is I'm going to use the old one as a template for making the new one. So let's pull it off the wheel here. And the spring's bent. We'll bend it back to close that up. So you do it one of two ways. You can measure it. You could measure it and cut a new piece, tie your knot on the spring where this one's tied, and just reinstall it. That's all there is to it. Okay, so I got the old one out, and just for the hell of it, let's measure this old one, the length. It is measuring 54 inches. So I've cut one here. I think I've cut it a little bit longer. Let me see. You want to get the replacement cord the same length as your old one. Let me do this so that you can see what I'm doing. What was it, 53 before? No, what did I measure? I'm 56 now. 56. So what I'm going to do is I'm going to take the ends, the two ends, and match them up, and then I'm going to tie my knot, and I'm going to leave about an inch of slack, or an inch of cord free at the end, because then that will put me at the correct length. Because this one's cut 2 inches longer than the original. Got that tied. Let's check this again. I can trim the excess off after. Now I need the spring. What I want to do is introduce the spring onto the cord and then tie another knot to lock it in place. And that should be it. That's our new string. See how it wraps. So what I did is I cut a dial cord and installed it, and it's too tight. Shouldn't be able to play a tune on it. But the spring is not even in play here, and the string is tight enough, which is not good. We got to have the spring tension as part of the dial cord. I mean, I could leave it like that, it's working, but what I did is I'm going to cut another one. So the original dial cord was 54 inches, and I cut this one at 56, and we're going to try it again. We're going to have 2 inches extra as our knot. I'm going to tie this. Okay, second try, I got it bang on. This is correct. I got it strung, and this is how much slack I have in the cord right here. So that'll be my spring, will take up that slack. So now what I need to do is I need to get a knot in the end here to hold that spring, and then I need to clip it on to the hole here. And then we're done. And almost done. And there it is. It's all in. Just testing it for full range. Got right amount of tension on our spring, right amount of slack. The only thing we need to do now is lock that nut, and you can do lock the nut or lock the knot. And what I use is just a little bit of paint, because it'll flow into the knot and it will lock it in place. You could use glue. I just don't have any glue here right now. So I think the paint, once the paint dries, it'll lock it in place. And then I'll need to do this as well. And this needs to be okay. To align our pointer back to our marks. Perfect. And then we'll have to lock this in place too. Let's let that dry. New dial cord. So that pretty much wraps this one up for all I'm going to do to it today. I'm not going to touch the tuner at all. I did do a AM alignment, and that kind of woke it up quite a bit. And the FM, you know, with all those bad resistors in there, I would have to go through and test every one of them to make sure that they're within tolerance. And I know I just did some spot checks on the tuner, the FM tuner and the AM tuner, and there's a lot of resistors out of tolerance. Here, for example, just in the power amplifier, I pulled out 16 resistors that were failed to meet tolerance. So this and this new capacitor that I put in the power amplifier made a world of difference. You know, we started off, I did my baseline test, and we were getting 7.8 watts out of the one channel. And then after I did my repairs and modifications, it went up to 12.25 watts, which is a 57% improvement just for the power amplifier alone, the handling. But back onto the tuner. The tuner needs a lot of work, from the standpoint that the resistors are bad, And I don't think I have bad capacitors, but it does need resistors, and then it would need an alignment after it's done. And I do not have the proper manual for doing alignment. I have a manual for the SR-222, which is similar. It's similar, but it's not the same. And there's still a lot of differences between this tuner and this tuner. So I'm not going to go there. I'm not going to touch the FM tuner. It seems to be working okay, kind of okay. Here, we'll show you. Turn this up. The problem is, one of the problems I'm having is I'm not tuned to a station, and then my meter's at 5 bars. It's already pegged. Well, that's a problem in itself. And I think that might have something to do with the resistors. But let's just go through the band.
Vous écoutez ici.
Make my way through the
See here, the meter actually goes down to about 2.5 in between stations. It's not great at picking up weak stations either. The strong ones come in really good. Get a lot of distortion. This one's coming in good.
Lush music and conversation.
Ty Jordan on Virgin Radio.
So the stations on the bottom end of the band are coming in pretty poor. The ones on the top come in a lot better and stronger and less distortion. So the tuner does need work, the FM tuner. Here, let's try the AM out. The AM was working a lot better.
Conservative Party ने Federal Liberal सरकार पे सवाल
Premier, and good afternoon, everyone.
Got no problem on AM.
In Alberta, which means that our
In sports in the NFL, playing in the fourth quarter.
KZA Edmonton is AM.
leads you to 60 traffic.
Oodle Noodle was born.
Yeah, so you get the idea. The AM's working great. FM not so much. But it's still working and it's pulling into stations, and with a good strong signal, like I said, it sounds good. So I'm not going to do anything to it at this point. What I've done is replace that power supply capacitor from, well, it measured at 850, and I replaced it with a 4700. Replaced the dial string that I screwed up and butchered myself, and replaced, like I said, 16 resistors in the power amplifier, which really woke it up, and it's now more balanced and precise. I'm going to give this receiver a test drive just to see how it performs. I know it's not a great performer. It's not, you know, top of the line model or anything, but I think it's good now. It's got some, it's been improved. Let's say. Let's put it that way. All right, that's all I got for this one. I'm gonna move on to more stuff. So again, Happy New Year, and hope to see you again soon. Thanks for watching.